Now we're going to talk about two things. First, we're going to talk about broadening your selection, and then we're going to talk about combining commands. Broadening your selection is really, really simple, and it largely involves usage of the star and other things. So let's see where we are. We're in text, so let's see what's here. Okay, cool. If I ls, I see these things. What if I only want to see files that start with the phrase all? I can type all star. And right there. Hey, now you're an all-star. If I want to see files that start with cat. Boom, like that. What if I want to see files that start with all and have an E in them somewhere? So what if I want all star, E star? So I have an E in the file name somewhere. So these are files that start with all and have an E somewhere in the file name. Right there, all exchanges strings, people, and places. Cool. That's star. Star is incredibly useful. Star just completes everything. Star is the command that you're just going to use star a lot. So there are a few other things that you can do, and they're a little more obscure in terms of not many people use them. You would use them if you were bash scripting, which is something that in machine learning you should not have to do almost ever. Hopefully you can... if you're good at bash, then... if you're good at shell scripting, then great, but for production systems, don't do that. But one of the things is you can do ls a through z star. This is all the files that start with letters a through z lowercase. But if I do a through z, I just get the README because it starts with a capital R. I can also do ls a through z. I can, and there's you can put numbers in here as well. Basically, the brackets allow you to search for files that start with a given thing. So I can do like a B, E, and those are the files that start with A, B, or E. If I put, let's say A, C, these are the files that start with the letters A or the letter C. So there you go. You can make a thing so you can actually figure out which files start with like one of a number of letters. And that's really, obviously, that's useful because sometimes you do want to find all the files. Like sometimes there's often directories with a whole bunch of files that have numbers in their names or like in the beginning of the name, and you want to find all the files that start with 1 or 2 or 3, but none of the rest of them. Well, then you would just do ls 1, 2, 3 there, like that. Obviously, there's no files like that here, but you could do that. Let's go into the SGMs directory briefly, just so so like... Here, so I could do ls right to 0, 0, and I do like 1, 2, 5, 7 star. And it gives me 001, 002, 005, and 007. That's pretty cool, right? So there we go. You auto-completion like that. That's really nice. You can also... There's another way of doing this where you use Twiddle Braces. So instead of doing that, you can do this... So instead of using bracket, I use brace, and it's the same sort of thing, but it's auto-expanding this thing out. So I'm going to teach you the difference between these in a later section when we talk about echo, but for now, it's very similar. What this line here, where's my mouse? What this line here is doing is it's auto-expanding this. So what it's ended... So I'm actually going to do... If you type ls A, B, C, D, what that ends up doing is it ends up auto-expanding to A, B, A, C, A, D. Like it will just actually auto-expand everything, which is really nice. So, and you'll see how that matters later. The other thing that you can do is you can have it do like, and I know this is a little weird, but you can do ls, 0, 0, 0, ... 21 star. Okay, so you notice how it gives me a bunch of things. It says no such file or directory. But you see that it gave me everything else in this directory. So what if I do 0 to 21 star? It does that again. Basically, you can have it autocomplete numbers using a double dot as well. That's kind of unusual. You usually don't have to do that for any reason. The other autocompletion that is really, 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 I cannot tell you how many times per day I use this, and I cannot tell you how few people I see using this regularly. It's really strange that people don't use it. So I'm going to go back into the SGMs directory. I'm sorry, let's go back into the text directory. So what if I ls cat, Feldman, and readme? Okay, there we go. Basically, I just gave 3 different things in the command line. What if I only care about the last one? What if I want a new command, like new command, but I wanted to do readme and just the readme.txt? You're going to learn about exclamation mark, or as they like to call it, the Linux gurus like to call it bang, because it's what it, in any case, if you use exclamation mark $, what that means is give me what was in the prior line in the last entry, because $, means last on Linux. And it will autocomplete to the last thing you just wrote, which is readme. So if I do ls 0, 1, 5, 6, 7, 2, 3, it's 2, boom, it won't do that. But if I do then ls that, the last thing I typed is 2, and it'll give me the 2. So why you'd want to do that is because you will often be working with a file, doing things with that file, changing, I did one thing with a file, now I want to do another thing with the file, now I want to do a third thing with the file. And by doing that, you can just keep hitting this thing over and over, and it just keeps, it's that thing. If I don't want that, so let's go back to the command where I had the ls cat, Feldman, and readme. What if I want the Feldman instead? Well, I do ls that, but now I want the thing on that line that was the second argument. :2 gives me the Feldman, cat colon. And you notice that when I hit up, it doesn't go back up to exclamation mark :2. It goes back up to that. It literally auto-completes it, so that's what it was. So if I go back up to here, if I do ls1, it's the cat descriptions. What if I do 4? What if I go ls4? Bad word specifier, because there wasn't a 4th thing in the line. I don't really often use this, except I sometimes will use this. Sometimes it is useful, but I will almost always use this over and over and over. It is super, super useful to use that, and I'm going to explain why once we get into parsing and manipulating files. That's absolutely necessary. The next thing we're going to get into is combining commands. So when we combine commands, so I'm still in this directory, in this text directory. So what if I ls and I get all this stuff? Let's pretend it's a directory with a bunch of big stuff. And I just want to find the files that have the phrase org in them. Well, we already learned what grep does. Grep searches for a phrase. So if I take ls and I pipe it into grep org, what this will do is it'll return ls returns everything, and then it will pipe that into the grep command, and grep is just searching for org, and it'll give me just that. Well, you may say, why would you do that as opposed to like just searching for, like why would you not do that as opposed to just ls, org like this? Well, sometimes, what if I want all the files that don't contain the word org? ls piped into grep-v org. Boom. There's all the file names that don't contain the phrase org. So pipe is really nice because pipe allows you, and pipe is the heart of a lot of what you're going to do when you're using Unix commands, is because pipe allows you to string a lot of commands together. I'm going to do one more thing just to show you what you can do. There's one more command I'm going to use in the combining commands thing. What if I want to take the output of this and put it into a file? I can use the right arrow and say some file, or whatever, some tile.txt, .hi. Boom. And now if I ls, you see that it's there. I'm going to ls ltr and show you I just created this thing. I should have called it file, but whatever. Here's this file. And if I less some tile, there, see? There's all the stuff that was in that file right there. So I can take the command of an output and put it into a file. I can also append. So what if I do this? I'm going to do ls a star into some tile, and I see some tile. There we go. But I also want the Feldman. So I ls f star. If I do this, it's going to overwrite it. I just overwrote the file. But what if I want to append? Well, it's simple. I'm going to do that again. And now, instead of doing this, I use two of these. If the file doesn't exist, it'll write it to the file. And if the file does exist, it'll append it to the file. So now if I less that file, you see how I just used that command? See how it's really nice? I can actually use pound $, and boom, there's the file, and you can see all the things. You can see the alls I put into the file, and you can see the Feldman that I put in. So there, now you know how to write things out to files, which is, of course, incredibly useful in Unix for any reason. You will need to write things out to files. So, for instance, what if I'm going to look in all people again? What if I want people whose names have an E in them? I can grep E in all people strings into names with E. And I less that file. Boom, and all of these names have an E in them. And I can do the same exact thing. I can grep -VE names without E. And now I have all the names without the letter E. So isn't that nice? Now you're now learning how you can start to do file processing by using these commands and stringing them together. And that's the whole point of Unix commands. For machine learning, for data science, for really any sort of analysis in file processing, you will very, very often want to search through files and find instances of things and put them in another file. And I've just shown you how you can do that. You use grep, and you redirect that into another file, and you're done. However, a lot of you are saying, yeah, but sometimes I want it and it's in the 5th column of a file. I'm going to teach you that it's in a future lesson. But now you have seen using the pipe command. So what if I do this? What if I grep -VE? What if I want all the files that don't contain the letter E, but all the names that don't contain the letter E, but, names, other, here, I'm just, other, but do contain the letter A, but don't contain the phrase CA. Oh, oops, I didn't put the grep in there. Grep. Boom. These are the names that contain E and A, but not CA. What if I only want the ones that contain CA? Well, I know this is kind of redundant, but I do this, and I'm going to look at that file again, and here's all the names like that. The names without E, but with a CA. So there, now you can see how grep can be used, and you can do that with files as well. Obviously, I can do ls, and ls this directory, or I can do find. For instance, if I'm in this directory and I find piped into grep, I know that I had a file in there that started with. I had a file in there that had a CO in it. Oh, I didn't. Okay, maybe there. I had a file that had a cat in it, but I don't know where it is. I find. Okay, here's all the things. Actually, I had a file that I had the number 007 in it. I piped into grep 007, and there's that file. So there, now you can learn, you can string together looking for files to find specific files. So now you can find files. So now you're understanding what grep does, and you're understanding what find does. You can string these commands together to do all sorts of things. These are all great. But the next lesson is going to be broken into several things, and it's going to be the meat of things. It's going to be how to parse and manipulate these files of any kind, and you can do a whole lot more than what I've shown you so far, and that's going to be in the next few lessons.